Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, safety and concurrency. Algorithmic trading demands ultra-low latency, rock-solid safety, and efficient concurrency. Traditional languages often fall short when dealing with high-frequency data feeds, complex order execution, and managing risk across multiple DeFi protocols. This lesson details why Rust became the optimal choice for rewriting our core trading engine. Our initial trading engine, built in TypeScript, suffered from unacceptable performance degradation as complexity increased. After 2 years of development, scaling became impossible. Rust offered a pathway to significant latency reduction and memory safety, critical for minimizing slippage and maximizing Sharp ratio. Benchmarking showed a dramatic performance improvement after migrating from Go to Rust execution. Latency dropped from an average of 89 microseconds to just 12 microseconds. This was achieved through Rust's zero-cost abstractions, fine-grained control over memory management, and avoidance of garbage collection pauses, factors that are paramount when competing for liquidity depth. Rust's ownership and borrowing system provides unparalleled concurrency safety. The compiler enforces thread safety, eliminating data races and ensuring consistent state across multiple trading threads. This is crucial for handling simultaneous order executions and real-time risk assessments without compromising data integrity. Rust's memory safety guarantees prevent common vulnerabilities like buffer overflows and dangling pointers, which are particularly dangerous in the context of DeFi smart contract interactions. Secure and predictable memory management is critical for mitigating risk of ruin when deploying capital to automated market makers, AMMs, and lending protocols. Our architecture uses customized agentic loops written in Rust to handle data ingestion, model execution, and order placement. These agents are enhanced with a private retrieval augmented generation RAG system, also implemented in Rust, to access proprietary market intelligence and risk parameters in real time. Rust's support for parallelism and concurrency makes it ideal for scaling our trading engine across multiple cores and machines. We leverage libraries like Rewrote for data parallel processing and distributed task execution, allowing us to handle increasing data volumes and trading activity without compromising performance. Looking ahead to 2026, we are exploring custom hardware acceleration using FPGAs to further reduce latency. Integrating advanced AI models directly into the Rust-based trading engine will enable more sophisticated market analysis and predictive capabilities, enhancing our competitive edge in the rapidly evolving DeFi landscape. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.